Hey everyone, welcome again. In this video, we are gonna look at Caffeine. We will do some hands-on activities on the caching. Two things before we start. First, if you're an absolute beginner on the caching, I suggest you check out the previous videos in the same playlist where I have covered the fundamentals of caching, some important concepts like cache hits, cache misses, cache consistency, expiration, invalidation, and so on. And second, if you like this content, please subscribe, like, and comment. Now that's out of the way, let's start the topic of this video, which is Caffeine. Caffeine is a high performance Java caching library. So first things first, this is a library. And by library, we mean whenever we want to use the Caffeine, we need to use the corresponding dependency in order to use the functionality because it's a library. And to do that, we need to use a dependency management tool like Maven or Gradle. This is a library. That means whenever we are using the dependency via Maven or Gradle, we get a set of classes or interfaces that we can use in order to implement the caching behavior in the application so that we don't have to rewrite everything from scratch. So Caffeine is a library. That means in order to use the functionality provided by Caffeine, we need to add the correct dependency in pom.xml if we are using Maven or in the Gradle config file. All right. The purpose of any cache in the system is to store the frequently accessed data so that we don't have to go back to the original source in order to get the same data. And so one of the most important things when we work with any caching solution is how do we populate the caching. So the first thing that we will see is how to populate the Caffeine cache. In Caffeine, there are mainly two ways to populate the data. The first one is of course manual. We will see how it is manual. So we have a class cache.java provided by the Caffeine library, and we use that class to implement this kind of population logic, which is manual. And the second one is using LoadingCache. So that means in this case, we don't have to populate the data manually. We can use it to populate the missing data on demand using CacheLoader. So LoadingCache is also a class which we get from the Caffeine library, and this uses a cache loader. We will see how it uses that. We will see that in the hands-on activity. But for now, just focus on two ways of cache population, which is manual using cache, and another one is using LoadingCache by using the cache loader internally. All right. So let's head on to Spring Initializer and set up a simple Spring Boot API. We can use any simple Java project. I'm going to set up a simple Spring API because many people are familiar with it and they find it easier to relate. Nowadays, almost everything is microservices and people are working with Spring Boot APIs. So I'm going to set up a simple project, and in that project, we will introduce the Caffeine caching library and we will see how to use it. So let's start. Here we are on the Spring Initializer page. So let's prepare a new project. I'm going to use Maven. All right. The language is going to be Java 3.2.1, which is the default setting as of now, is fine. Let's change the group. Okay, name of the artifact, Caffeine hands-on. We'll change the package name, and that's all. I'm going to select the default, which is 17. You can select 21. We are not going to use any specific 17 or 21 features, so that's all fine. Add the dependencies. We are going to create a REST API, simple REST API. So Spring Web is all we need. And although we will be focusing on the caching part, that means ideally we have a data source. On top of that, we are creating the cache, right? But in this case, we are not going to set up any database. We will set up a dummy database in the project itself. So I'm not going to add any DB specific dependency here. So let's generate the project and we'll open it in IntelliJ. This is it. We have unzipped the project. So let's open it with IntelliJ. Let's give it some time while it sets up everything. All right, so let's check out the pom.xml. As you can see, this is a simple pom.xml. There's nothing special about it. Checking the dependency, we have a simple dependency, which is boot starter web. And as I said, Caffeine is a caching library. In order to use the Caffeine, we need the corresponding library. So that means we need to find the correct dependency that we can add in this pom.xml. So let's search for the Caffeine dependency and we'll get the dependency section. We'll put it in the pom.xml. And here let's simply search for the caffeine cache maven to find the right dependency. Go to this link and we can select the up-to-date version, which is 3.1.8 as of now, and I'm going to copy it. So let me copy this one and we'll go to the pom.xml. We'll add a new section here, reload the project. All right, it will now download the dependency, and if we check the external libraries section, we should see the caffeine in the external libraries. And here it is. So we see the correct version 3.1.8. It means it was downloaded fine. Now that we have the dependency in the project, now that we have the library, we can simply use it. But before that, let me write a controller in order to set up the API. Okay. So let's go to the main folder, and here in the main class, I'm not going to create a separate package or something like that. So we'll use the same class. And here we can define all the controllers and whatever we need in a single class. So first of all, let me copy the dummy data, and here it is. Okay, import the repository. So what is the purpose of this data DAO? As you can see, this is a DAO which is annotated with @repository annotation. That means it plays the role of DAO layer. The purpose of this DAO is to communicate with the database in order to get the data, in order to fetch the data from the database. But as I said, we are not going to use any real database. We will use some dummy data. So in the data DAO, we have two methods, get all and movie by director. That means we will pass a director and it will return the corresponding movie. But for the data, we have a dummy data set that is a simple map with key value pairs, where key is the name of the first name of the director and the value is the name of movie or the title of the movie. So the get all will return basically the whole map, all the keys and all the values. And if you want to fetch a specific movie by director, it will look up that movie in the hash map. That's the one. And it will return the corresponding movie. So that is going to play the role of database and DAO. All right. Now let's write a simple controller in the same class. We will say movie controller. Okay. And in this movie controller, we will auto var the data DAO, because we need to read the data from the database, in this case, which is dummy data. And we will write a simple get mapping method, which will return a string, and we'll name it movie by director. Okay. And we will also accept a path variable of name director. Okay. And here we will return the value of that movie. That means we will call DAO dot movie by director and will pass this director value that we get in the request. Okay. And because we are accepting the path variable, we need to provide one. So let's say the path is movie slash director. That means whenever there is a get request, the client will pass, it will hit this endpoint, which is slash movie, and it will pass the name of the director as a path variable. And we will pass the same value to the DAO, will get the movie for that director, and that response will be returned back to the client. Okay, so let's try to start the server. As of now, we have only added the dependency of caffeine. We are not using any feature. We are simply testing the API. So let's start the server. And as we can see, the server is up. So let's try to hit the endpoint and get the movie by the director. Here you see this is the address of the API, localhost 8080. The endpoint is movie and the name of the director. So I'm passing the name of the director as Chad. Let's hit enter and we see the name of the movie John Wick. So let's understand what is happening here. When the client calls this URL, this particular endpoint will be called, which is this one, yeah, movie slash name of the director as path variable. So we get the name of the director as path variable, and then we pass the name of the director to the method which is in the DAO. And in the DAO, this is a simple key lookup to find the movie of that director. And that's what we see as a response. And in the console, we see this message, which means DAO calling this method and name of the director. That means the method of the DAO was called. And in case this is not the dummy data, and if this is, let's say, a real database, in that case, we can see that a real call will be made to the database to fetch the movie for the director. So let's try to make the same request again. And we see an error. Let me start the service. So the service is up, and here we reload the page. So we see the movie John Wick, and in the console we see this log message. All right. And if we hit the same URL again multiple times, if we make the same request again multiple times, every time it will be sent to the API endpoint to the controller, and the controller will call the movie by director method of the DAO. And each time we see the log message on the console, that means for each request, a call to the database was made. And that's the point here. For the same request, we are hitting the database repeatedly again and again. So we are making additional calls to the database for the same dataset. And if you remember the concept of caching, this is the perfect candidate for the caching. We can cache this data so that we don't have to trigger a DB query for the same dataset. In case we call the same API endpoint again for the same director and that movie is in the cache, we can simply send the response by reading the data from the cache instead of going back to the original data source, which is the database in this case. So we understand the problem now, how we can use caching, in which scenarios we can use caching. We already have the dependency in the pom.xml, so in the project. The next step is to initialize the caffeine cache and implement the caching in this flow. All right. Now that we have decided to initialize the caffeine cache and to implement the caching in this layer, in this flow, the question is, where do we initialize the caching logic? We want the cache to be initialized once so that we don't have to reinitialize the cache again. Otherwise, we lose the benefit of caching the hot data. If we are reinitializing the cache again and again for each call, then it doesn't make any sense. So the idea is we will initialize the cache once, and that will be valid, let's say, for the lifetime of the server. And while the server is up and running, the data will be cached in the same instance of the cache so that we can read it again and again. And how do we do that? There are different ways. We can create a bean and we can initialize the caching logic with the help of a bean, or in a simple scenario, we can simply initialize the bean in the post construct method, which will be called only once. So let's do that. First of all, we need to have an instance or reference of that cache. For that, let's have a variable of type cache, and notice this is coming from caffeine cache. Okay, it accepts two type parameters for the key and the value. We are going to have a simple cache, so the key value will be string. All right, name of the cache, we will say this is movie cache. And the next step is to initialize this movie cache. To do that, let's add a post construct method, and we will name it init cache. And here in this method, we will initialize our caffeine cache. Let's do that. And we will say caffeine dot new builder dot build. As simple as that. Here in the post construct method, we have initialized a new caffeine cache with the name of movie cache. The type parameter of the key is string, and the value type parameter is also string. That means the key and value are going to be of type string. Okay. So now that we have initialized the caffeine cache, how do we use it? To do that, what we can do, instead of calling the method on the DAO, which is DAO.movieByDirector, in this endpoint, we can say something like this: movie cache dot get. And here we can see different variants of the get method. This method accepts the key, also a function. We will see soon how to use this. The second method accepts multiple keys. It is also named as get all. That means if we have multiple keys and we want to fetch the data for all the keys in one go, we use the method get all. Get all present means it will return the data for all those keys if the data is present in the cache. And similarly, for the single key, we have the method get if present. So it will return the data if the cache has the data for the key. So let's try to use this one first. Get if present, and we will pass the key. That means the director. We want to see if the value for the director that we are looking for exists in the cache or not. Let's also print it for now. And we'll put a message from the cache. Notice we have only initialized the caffeine cache, and now we are trying to get the data for the key. There is no data in the cache that we know. Okay, so let's start the service. The service is up. Go to the browser. Let's make the same request again. We see the response John Wick, because if you notice, the response is being returned from the DAO, not from the cache. And we can see that message in the log as well. That means there was a call to the DAO and there was a DB query. Although in this case, we have the dummy data, but consider it as a real query. And you can see there is another message which says from the cache null. That means this call returned null. There is no data in the cache for this key. And it's not surprising, we know the cache is empty. Now, this kind of approach is called manual loading in terms of Caffeine terminology. So notice we are using the class cache.java from the Caffeine. We have just initialized the Caffeine cache. We have not populated any data. So we need to fill this cache manually, hence the manual loading. So how do we do that? To do that, we will use another method of the cache. Let's try to do that as well. So we will say movie cache dot get, and this time we will use this method. We will pass the key, but we will also pass a function which will handle the cache miss. That means if the data is present in the cache, it will return the value. Otherwise, it will try to calculate that value. It will try to fetch that value based on the implementation of the function that we provide. So let's use this method. First of all, we need to pass the key. This is director, the value that we are getting as part of the path variable in the request. All right. And the second part is a function that will try to fetch the value in case the value is not present in the cache. And we know if the value is not present in the cache, we need to read the value by calling this method of the DAO, which is movie by director. So we can say DAO : movie by director. This is the function implementation. We are saying if you find the value for the key in the cache, return the value. Otherwise, call this method to find the value of that director and cache it. So in case of manual loading, you see we have to pass the function definition every time when we are calling the get method of the cache, and the responsibility of handling the cache miss lies with the cache or the developer who is writing this code. All right. So now what we can do, let's move this code to the return. So what we are doing, instead of calling the method of the DAO to return the response, we are simply calling the cache. And if this is a cache hit, the cache will return the movie name. If it is a cache miss, the cache will call this method because that's what we have passed as part of the function. So let's restart the service. The service is up, and let's make the first request. We get the value John Wick. Notice the cache was empty for the first call. So we see the call to the DAO. We see this log message, which is in this method DAO calling movie by director, name of the method, and the value that was passed, which is Chad. All right. So for the first call, the cache was empty. It was a cache miss. Notice it was a cache miss. There was no value present in the cache. So the caffeine called this method. That's why we see this log message. Notice because it was a cache miss, so the caffeine cache called this method to fetch the name of the movie, the title of the movie by this director. It not only called this method of the DAO to return the response, but it will also cache the response. So that means it will also store that value, which also means if we make the same request again, it should not go to the DAO method. It should be a cache hit. That means we should get the response from the cache and it should not call this method. So for the same request, if we make the same request again, we should not see this message on the console. All right. So let's retry the same request. Let's make the same request again. We see there is no change in the response because of course the title for the director chat is going to be John Wick. But notice in the logs, we don't see additional log messages from the DAO. Why is that? The reason behind that is because in the case of first call, this was a cache miss. So the caffeine cache called this method of the DAO. It returned the value John Wick back to the client. But it did one more thing. It also stored the response in the cache so that in case the client makes the same call again, it will not be a cache miss, but it will be a cache hit. So that means if this is a cache hit, the cache can return the data from the cache memory itself. It doesn't have to call the DAO. And that's why after the first call, when we made several same calls again and again, the DAO was not called. That's why we don't see those messages on the console. But if we change the director, let's try a different director. So John. If we make another call for John, we see the movie is Die Hard. And if we check the console, we see additional log message because in this case, John doesn't exist in the cache, which is a cache miss. So the caffeine cache will automatically call this method because that's what we have passed as a function definition. But in this case also, it will store the value for the future accesses. And so if we make the same request again for the John, we see it will be returned from the cache. We won't see any additional messages from the DAO. All right. So that's how the cache works. That's how this manual loading works. The only downside is we have to pass the function definition with each get call. Basically, we have to handle the cache misses. We have to find the missing data in case there is a cache miss so that cache can store this data. So you see, we know how to use caffeine cache. In this example, we successfully implemented the cache, but the only downside is the population logic is manual. That means we have to handle the cache misses by passing this function with each get call. Can we do it in a better way? Is it possible to change it so that we don't have to do it manually every time when we are trying to get some value from the cache? Well, there is another way to populate the cache in Caffeine. As we discussed in the beginning of this video, there are two ways, manual, and the second one was by using the loading cache. So if you notice here we are using cache, that's why the process is manual. We can change it, we can use an automated way to handle the cache misses. To do that, we need to change the type of the cache. Instead of the cache, we are going to use loading cache. Notice this is also coming from Caffeine. So what we did, we changed the data type of cache from cache to loading cache. All right. The type parameters are going to be same, string, because the structure of the cache is not going to be changed. It's only the way we handle the cache misses, and that's by using loading cache. All right. Notice here it is now giving us error because we need to pass one more thing, which is the CacheLoader. And if we check out the build method, you see it now accepts a CacheLoader. What is a CacheLoader? CacheLoader is simply a function in which we provide some information to Caffeine cache where to find the missing data. So let's say when we try to access the value from the cache, if it doesn't find the cache, how does it find that value? It will do that with the help of CacheLoader. And in this example, we have that function. We have a similar function, which is DAO : movie director. That can be the CacheLoader. So we are saying we don't want to handle the cache misses every time when we are calling the get method on the cache. So use the loading cache and use this function as a CacheLoader. If you find a cache miss, if you can't find the data in the cache, use this function to fetch the value and store it for the future accesses. That's what it's going to do. And now that we have a loading cache, we don't need to change anything. We simply need to change the get call. We don't need to pass the method definition here. I mean the function definition here. We can simply pass the key here, which is director. All right. So now it's much cleaner, much simpler to understand that we are simply passing the key to the cache, which is also easier to understand that we are simply trying to get the value for this key. And if it doesn't find the value in the cache, it will call this cache loader to fetch the value and to store the value. So let's restart the service and test the same example with the help of LoadingCache. The service is up. Let's retry the same request for the director John. We should see the output die hard. And if we make this request, we see the output die hard. And let's check the logs. Here we see the log DAO calling method name and John. And notice, because for the first call, the cache is empty, it's going to be a cache mess. So with the help of CacheLoader, it automatically called the method of the DAO. That's why we see this message. All right. And if we retry the same request again, this time this should be a cache hit. And it is. That's why we don't see the message from the DAO for this call, because for after the first call, it stored the value. And let's change the director, make it chat. We see John Wick. This is going to be a cache mess because it's a new director. And in the logs, we can see that. But if we make the same request again, this will be a cache hit. All right. So we saw how to populate the caffeine cache. We saw two ways. One is manual using this one. And the second one is using LoadingCache with the help of CacheLoader. So we will continue our discussion on the caffeine cache on the other sections like eviction and invalidation and other things, but we will continue with the LoadingCache. So let's move on. Okay, so we have covered both the strategies of cache population, which is manual and via LoadingCache. We are now filling the data in the cache, and we have also seen how to utilize the caching in the application logic. The next thing we will learn is eviction. I suggest you check out this video to understand eviction in detail, but in case of caffeine, there are two main policies, eviction policies available. The first one is size-based and the second one is time-based. And under time-based, we see two main categories again. One is based on the access of the value and the second is based on the write. So in case of access, read and write both are considered as a valid access. But in case of write, which is this one, only the write operation is considered as an access. All right. So in case of size-based eviction policy, we define a maximum size of the cache. If the cache is full and we have to add one more element to the cache, we of course need to evict some elements. So in case of size-based eviction policy, the items will be evicted when the cache is full. It is based on the maximum size that we define. In case of time-based eviction, the eviction is defined by the time period that we have defined. So if it is access-based, that means if the entry has not been accessed, that includes read and write, let's say in time t, then that entry will be evicted. Similarly, for the write approach, let's say if the entry, there has been no write operation on that entry in time t, then the entry will be evicted or will be considered for the eviction. And we will see the examples of all these policies. So let's head on to the IntelliJ and see the practical example of these policies. So here we have the same movie cache, which is of type loading cache. That means we are handling the cache misses automatically. We saw it in the last section. We are also providing the cache loader. Now we need to learn eviction, and the first one is size-based eviction. How do we define the maximum size that the cache can support? All right, let's say we are short on the memory. We are a little bit conscious about the memory and we don't want to put all the data in the cache. There has to be a limit, there has to be a threshold, and we decided to go with this size-based eviction. So we need to define a maximum size that this cache can store, or the maximum entries. All right, to do that, we can add a method which is provided in the builder, and you can see maximum size and maximum weight. In case of maximum size, it is the number of entries, the max number of entries. And in case of maximum weight, we define a logical weight, but for that we will also have to implement some kind of mechanism to associate certain weight to entries. all right, so that it can calculate maximum weight and it can, let's say, evict the entry with the maximum weight, stuff like that. So in this case, we will go with the maximum size. We will define the maximum size, the max number of entries that this cache can store. And let's say we give it 3 for the example so that it's easier to test. Now the cache can store at most 3 entries, and we have also defined the cache loader. So it is as simple as that. Let's start the service and see how this maximum size will be applied when the cache is full and how the entries will be evicted. Okay. The server is up. Let's go to the browser. Chad is the first request we are going to make. We make the request. We see the value John Wick. And in the console, we see one log message because this will be a cache miss. So the cache loader will call the function, which is basically this one, movie by director method in the DAO class. And it will call the database. So we see this log message. All right. Let's try another director, John. This is now the second request. And we see the value Die Hard. And again, this is a cache mess. So this will be handled by the cache loader, which will call the DAO. And so we see another log message on the console for the director John. And similarly, let's try another director, James. And we see the movie Terminator 2, Judgment Day. And similarly, this will also be a cache miss. So we see the message from the DAO on the console. So there were 3 cache misses, and 3 times it called the cache loader, it called the DAO, and so we see 3 log messages on the console. But that also means for each cache miss, it will call the cache loader and it will store that value for the future access. So let's say if this is the cache at time t, so after 3 calls, we have now 3 entries in the cache, one for Chad, one for John, and the third one for the James. So there are 3 entries in the cache, and so if we try to read the data for the Chad, let's pass the Chad again. We see the value John Wick, but if you notice in the console, we don't see a new log message because it will be a cache hit. After the first call, the cache now has data for the Chad. And so it will not call the cache loader because it is a cache hit. So now at this time, in the cache, there are 3 entries for Chad, John, and James. But it also means that we have reached the maximum size because the maximum allowed size is 3. That means the cache can store at most 3 elements. And at this time, it has 3 elements. So it has reached its maximum capacity. So now let's see what happens if we make a new request for a new director which is not in the cache. We'll select Christopher for this one and we'll make a new request. We see the movie name Mission Impossible Fallout, and because this will be a cache mess, so it will be handled by the cache loader, and we see the log message on the console. Now what will happen, because it has to add a new entry in the cache and the cache is already at its maximum limit, which is 3, allowed size is 3. So it has to evict one element. All right, it has to evict one element to make room for the new entry, which is Christopher. And that is the role of eviction. The eviction policy is size based. That means maximum allowed size, maximum allowed entries are 3, which is the case here. And in order to make room for the new entry, one entry will be evicted. This is to control the size of the cache. So now in the cache, we have Christopher and one entry will be removed. So to test the hypothesis, if we try to read the data of Chad again, so we'll make a new call for Chad. We see John Wick, but in the console, we don't see a new message. That means Chad is still in the cache. Then which one was removed out of these 3? So the documentation of Caffeine says, in case of the size-based policy, if we have to evict an item, the item will be removed based on the LRU policy, the item that has not been accessed in the least recent time. So it will probably be John or James. Let's try John. And in the logs, we don't see an entry for John. That means it must be James. And we see the value James. What this means is when we asked for Christopher, a new entry was added in the cache, but now that the size is greater than 3, it removed James like this. And so when we called this API endpoint again with the value James, it will result into a cache miss. It will be handled by the cache loader, and so we see the log message on the console for James. So that is size-based eviction policy. We define a maximum size, and when the cache reaches the maximum size, in order to add a new element to the cache, one item will be removed. The item will be evicted based on the LRU policy. Let's move on and see the examples of time-based eviction policy. In the time-based eviction policy, the items or the entries are evicted based on the time duration that we have defined and based on the pattern, whether it is access, that means read or write, or whether it is just the write. So now that we have a basic idea of time-based eviction, how do we implement it? So we still have the same cache, LoadingCache. So we can comment this one, maximum size, because we are not going to mix and merge the size-based and the time-based eviction. We will see both the examples one by one. So we have already covered the size-based eviction. We can comment this one. For the time-based, we will say expire. And you can see different variations of these methods: expire after write, expire after access, and simply expire after. So in case of expire after write, if the entry has not been updated in this duration, the duration that we pass, then it is considered stale and the entry can be evicted. In case of after access, if the entry has not been accessed, so that includes read and write operations both, then it will be evicted. We have the different flavors of write and access. They include parameters like duration with a time unit. So that's the only difference. Then we have the third method, expire after, that expects some kind of implementation for expiry class. Now this is a custom expiry policy. If you want to implement a custom expiry policy, then we can use this method. For this example, we are going to use expire after access because that's a bit easier to implement. That includes read and write both. So we can test the code with the access only by reading the entries only. But with minor changes, you can implement expire after write as well. You simply need to write the values, update the entries, all right, in order to test the code. So let's use this one, expire after access, and we will pass a duration of, let's say, seconds. So I'm going to say if the entry has not been accessed in 5 seconds, then consider this entry as a stale entry so that it can be evicted. So before we test this implementation, when to use time-based eviction? We use time-based eviction when there is a certain pattern, certain update pattern, certain access pattern of entries, and the staleness of that entry matters. Also, it is also acceptable a stale value within a defined bounds of time. So if you don't understand the eviction policy or time-based eviction policy, please check out this video. All right. So we have a loading cache and we have defined a time-based eviction policy, which is based on the access. We have also passed a duration of 5 seconds. So let's now start the service and test this code. The service is up. Let's read the data for James. And this is going to be terminated to judgment day, but at the same time, the cache will store this data, which is valid only for 5 seconds. And if we don't access this entry, if we don't access the value for director James within 5 seconds, then this entry will be considered as a stale entry that can be evicted. So we'll wait for 5 seconds, but before that, let's see the log messages. So this was, of course, a cache miss, which will be handled by the cache loader. And so we see the log message on the console for the director James. And in the meantime, let's use another director, Chad. And for Chad as well, it will be a cache miss. So we see the message on the console from the DAO. But if we access James again, which was a cache miss. So the data was stored in the cache, but we have not accessed this entry in last 5 seconds. So ideally, the entry will be evicted and we will see a similar log message again in the logs, all right, from the DAO. So let's try to read the data for James again. And if we check the console, we see the message from the DAO method. That means it was a cache miss. Because we accessed the data for James after 5 seconds, which is the defined time period here, the duration of 5 seconds. So the entry was expired because it was not accessed in a duration of 5 seconds. So that's how time-based eviction policy works. Let's test this again, this time for a new director. So we'll say George, and we see George. We see one log message, and if within 5 seconds, if we access it again, we don't see another log message for the George. All right. So that's expire after access. That's the time-based eviction in Caffeine. Let's move on. Similar to expire after access and expire after write methods, Caffeine also has a method which is refresh after access, which also accepts a duration. The difference is when we are using refresh after access by passing a duration, it means the entry will be eligible for a refresh after that duration. But let's say it is taking some time to fetch the new value from the data source. And during this time, if a client queries the cache for the same key, the cache will return the old value. While it is refreshing the entry, while it is reading the new value from the data source, if there is a query from the client for the same key, in case of refresh after access method, the cache will return the old value. And when the entry has been refreshed and it has the new value for the future accesses, for the next set of calls, it will return the new value. But in case of expire after access or expire after write, what happens when the entry has been expired, evicted, and it is reading a new value from the data source, and during this time, if a client queries the cache for the same key, it will block the client because it will try to read the new value. So that's the difference between expire after method and refresh after method. So let's comment the expire after access method and we will see how to use refresh after access. So this is going to be refresh after write. It also expects a duration. So let's pass a duration of seconds 5. Okay. In this example, you won't see much difference between expire after access and refresh after write because the value essentially is same in the dummy data set. So we won't see a refreshed value, a new value for the same key, but at least we will see the log messages from the DAO method. So let me restart the service. The service is up and let's retry the same request for George. This will be a cache miss, so we see a log message, and within 5 seconds if we retry the same request, okay, it was too short. So let me increase the duration. Let's say 10 seconds. Let me restart the service. The service is up. Let's retry. This will be a cache miss, so we will see a message from the DAO in the console. And after 10 seconds, this entry will be eligible for a refresh, but the refresh will only happen when it receives a query for the same key. So after 10 seconds, let's wait a couple of more seconds and we won't see a message in the console. We will only see the message on the console when we make another request. So the entry will be refreshed only when it accepts a new query, only when the cache receives a new query for the same key. Although it is eligible for refresh, but it will not happen automatically. So after 10 seconds, more than 10 seconds, if we make another call for the same director, this time the refresh will happen and it will be handled by CacheLoader. We will see a new value, but because there is no difference in the underlying value, it is essentially the same. So we see the same value as a response, which is Mad Max. We have made good progress so far. We covered how to initialize and use the cache. We also saw how to optimize the memory usage of cache by implementing different eviction policies like size-based, time-based. And we also covered how to refresh the entries. Next, we are going to cover two more things, which is invalidation and listeners. Let's talk about invalidation. So there are three similar looking terms: expiration, eviction, and invalidation. If we talk about expiration, the expiration says when the entry can be considered as a stale entry, when an entry can be considered as an expired entry. So if an entry is expired, it may be still there in the cache but not removed yet. So expiration is about when the entry can be considered as a stale entry, while eviction and invalidation, they are about removing those entries. So let's talk about the eviction policies. For example, in the time-based policy, the entry will be considered as a stale and will be evicted if it has not been accessed in, let's say, the last 5 seconds. So in case the entry is being removed due to the policy, due to the time-based policy, so this is called eviction. This kind of removal is called eviction. In case of invalidation, in this case also the entry will be evicted or removed from the cache, but this is being done explicitly manually, let's say by using a method. So in invalidation, we will see how can we explicitly remove the entries from the cache, how can we invalidate them. That is the difference between eviction and invalidation. And when we talk about listeners, we will see Caffeine provides a couple of listeners that we can use that can report the removal of entries that, hey, this item was just removed from the cache due to this reason. Let's see how can we implement the cache invalidation. So suppose we are also exposing an endpoint in the same API to invalidate the cache entries on demand so that it's easier to invalidate the entries whenever we want to. So for that, just for the demo, I'm going to expose a new endpoint, an HTTP GET endpoint basically, and it says invalidate and the key that we want to invalidate. Public string, name of the method, and that key is going to be path variable. All right. And to invalidate, it's pretty simple. All we need to do is if we have the instance or the reference of movie cache, we can simply say invalidate. So we see a couple of methods. Invalidate, if we pass a key, that key will be invalidated. It doesn't return anything if you notice the return type. Invalidate all, if we want to simply invalidate all the entries. And if we want to invalidate a set of keys, we can pass on an iterable. All right. So I'm going to use this one. Pretty simple. Just pass the key and that key will be invalidated. All right. And we can return a response. All right. So we added a new method and we are accepting the key as a path variable. Then we are simply invalidating the key by calling the invalidate method on the cache. All right. Let's start the service and test this code. And before we test, let me also remove this refresh after write for now. So we have a simple cache without any eviction policy. So let me start the service. All right, so the service is up. Let's go back to the browser, make the same request for director George. We see the movie title, which is Mad Max. And on the console, we see the log message from the DAO because it was, of course, a cache miss. All right, now if we retry the same request, it will be a cache hit. So we don't see the additional log message from the DAO this time. But what if we have to invalidate this entry? How do we do that? To do that, we'll call the invalidate endpoint, which is instead of movie, just change it to invalidate. And we see key George successfully removed because this time this endpoint was called. But that also means this key is no longer in the cache. So if we try to fetch the movie title of director George again by using the same URI that we did earlier, this time it will be a cache miss. So we see the title Mad Max, but it was a cache miss, and so we see an additional log message on the console. That means for the first call, it was a cache miss, so the DAO was called, and the value was stored in the cache itself for future access. But we invalidated the entry that removed the entry from the cache. And so when we retried the same request again for George, it was treated as a cache miss. Hence, we see the log message from the DAO again. So that's how invalidation works. Now that we have covered the eviction and invalidation both, we can finally cover the listeners. In Caffeine, we get two listeners, remove listener and eviction listener. So we will implement first and then we will understand the differences. So how do we define the remove listener and eviction listener? We do it when we define the cache. So in the init cache method, when we are instantiating the cache, where we define the eviction policy like expire after access or maximum size, at the same time, at the same place, we define the listeners. So let's do that. We have methods like remove listener. You see, it accepts a remove listener. And in the same way, we can define the eviction listener. So let's first provide the remove listener like this. Implement method. It has a single method on removal. And similarly, let's provide the remove listener here as well. And in this case, it's going to be string string. So let's change it string and string because the key and the value are of type string. Similarly for the eviction listener. Okay. So that means whenever an entry is being removed or evicted, this listener will be called and it will have access to the key and the value and the instance of removal cause. From this object, we can get the information about the removal or the eviction. So let's put some logs so that we can understand what's going on in this listener. So we can say key equals to O, or let's name it to key, and this would be value. Value was removed. Why? Because it is remove listener. And then we can also get the reason from the removal cause. So let's see what are the methods available in this removal cause object. So we get the methods like toString if it was evicted, and compared to name, is there anything else that we can use? Let's see, get, no. So probably we can use toString method. Yeah. And in the same way, we can also give the same implementation in the eviction listener. So let's change the O to key, the value, and in this we will change it to evicted to make a difference. All right. So we have both the listeners and we can test the functionality. How do we test it? We have the method to explicitly invalidate the key. So whenever we call this method to invalidate a key, ideally one of these listeners should be triggered. And we can also test the eviction, that means removal by the policy. For that, we can use the simplest, which is the size based. So we can have a maximum size of, let's say, 2, so that whenever the maximum size is reached, it touches the threshold, the one of the items will be evicted, and in that case also we should see the listener activated. So we have the maximum size 2. We also define both the listeners. Let's start the service and test the code. So the service is up. Let's go to the browser and we are fetching the movie for the directed chat. We see the value John Wick, and let's check the console. We see the DAO was called because it was a cache mess. All right. Let's try another director, James, and we see the movie title. In the logs, we see the DAO was called because it was also a cache mess. But now the cache has two entries, one for the chat and the second one for James. That means we have touched the maximum size. After that, if we try to access a new director, one of these entries will be evicted, will be removed from the cache to make room for the new data, because the maximum allowed size is 2. But that also means that when the entry will be evicted, one of these listeners will be triggered. So let's try to test that. To do that, we'll query another director, a new director which is not in the cache. So let's pick John. And if we try to fetch the movie for the John, that means one of the earlier values will be evicted. And you see, it was a cache miss. So basically the DAO was called for John. And if you notice, we also see the log messages from the listeners. That means one of the entry was evicted. Which one was this? We see James was evicted. So we see the log message that key James and the value, the movie title was evicted, was removed. And we see the reason that it was size-based policy. All right. So we saw whenever the entry is evicted due to the policy, both the listeners will be called eviction listener and removal listener. But what about if we invalidate the cache? So let's do that. Right now in the cache, we have two entries. One is Chad and the second one is John, because James was already evicted. So if we try to invalidate the key Chad, let's see what happens. So let me clear the console and we'll call the invalidate endpoint. And we can invalidate John, doesn't matter. So let me hit enter. It says the entry successfully removed. And in this case, we see that the removal listener was triggered. We see the message that the key equals to John and the value, the corresponding value was removed. And we see the reason is explicit because it is invalidation. We are explicitly invalidating the key. We are explicitly removing the entry from the cache. So when we invalidate the key, the removal listener will be called, but whenever the entry is being evicted due to the policy, both the listeners will be called. Now, there is one more difference between the removal listener and the eviction listener. The difference is the removal listener, whenever it gets triggered, the execution is asynchronous. That means even though we saw the log messages at the same time in the console in the previous example, but the removal listener is actually executed in asynchronous way. All right. So whenever we need the listener to be called in a synchronous way, we should use eviction listener. This is called synchronously. That means when the entry is being evicted, at the same time, the eviction listener will be called. But in case of removal listener, it may be deferred because it will be called asynchronously. So that is another difference between these two listeners. Also, we don't need to use the anonymous inner class that I have done here. You can simply pass on a simple lambda. But for the sake of simplicity, I have used the anonymous inner class so that it's easier to understand. All right. There is one more thing that we will cover with the caffeine cache, which is the map equivalent of the cache. Let's see what do we mean by that. So here we have access to the caffeine cache, in this case movie cache. What we can do, we can get the corresponding map by calling the asMap method. And notice this is a concurrent map, which is often the concurrent hash map. Now, if we have access to the concurrent hash map, we can use the flexibility of concurrent map, basically the atomic methods like compute if present, compute if absent, and even compute. The thing is, when do we use these methods? The idea is whenever we want to implement an atomic operation, we can use the compute methods of the underlying map. So consider in this example, in all these examples, we are handling the cache misses using CacheLoader. That means if the data is not present in the cache, we are using this function to fetch the data from the database. But what if we have to handle the updates as well? Let's say we have to implement a write through cache. That means the update needs to go through the cache, then to the database, because there are patterns where we update the cache first and the cache will update the data source. And when both the sources are up to date, then only we will acknowledge the write to be a successful write. In that case, we need to implement an atomic operation. We need to update the cache and the data source in one transaction as a unit. In such scenarios, we can use compute alternatives. We can use compute method or compute if absent and compute if present. If we are trying to implement an atomic operation, in such scenarios, we can get the instance of, let's say, underlying concurrent map, and we can use the compute methods. All right. So that's pretty much it for this video. In this video, we covered the basics of Caffeine cache, how to use that, how to implement the eviction policies, and so on. And I hope it gives you a good start to explore Caffeine on your own. Now, this is not the end. In this series, we will cover a few more caching solutions like Guava, Ignite, Memcache, and all those things. We will try to cover as much as we can. We will try to implement different recipes, and we will try to understand the comparisons, the differences between all these frameworks and libraries. So if you like the content, subscribe for more. If you have any question or feedback, let me know in the comment section. That's all for now. See you in the next video. Thanks for watching.